Hi everyone, and welcome to our session today. Naviteq using AI and MCPs to deliver self-service DevOps that works. I'm Elad Wellner, CEO of Naviteq. We're a DevOps service company working with tech companies across Israel and Europe, helping them to scale cloud-native infrastructure through automation and senior engineering expertise. Joining me today are two people who are the right interaction for DevOps and AI. Greg Snegovsky, our head of DevOps at Naviteq, who works hands-on with engineering teams dealing with real production bottlenecks every day, and Idan Nialovich, founder and CEO of Bluebricks, who's building cutting-edge agentic platforms to power next generation of DevOps automation. Now, this isn't a demo, it's a debate. You'll hear two strong perspectives. One is optimistic, the other one is a bit more skeptical. We'll be diving into the real-world question like, are AI agents ready for production? Can you trust automation to handle infrastructure without manual review? And how do we balance between speed and safety with DevOps involved? We'll wrap up with a live demo, practical advice, and time for your question. So let's jump in. Let's take a look at our agenda for today. We'll start by unpacking the DevOps bottlenecks, why self-service often isn't as smooth as it should be. Then we'll dive into what agentic automation and the MCPs actually means, with real-world use case from Idan and practical production insights from Greg. After that, we'll jump into a live debate. Are AI agents really ready for production, or are we getting ahead of ourselves? We'll follow that with a short demo from Bluebricks showing how this works in action today. Then we'll wrap up with some key takeaways and live Q&A. Feel free to drop your question into the Q&A panel at any time. We'll answer them all at the end. Let's get started. Idan, great to have you with us today, and welcome to our webinar.
Thank you, sir.
Can you tell us a bit about yourself and your background, and also give us some overview of what you're building at Bluebricks, especially around the AI agent and how they're changing the way teams approach DevOps.
All right, so thank you and glad to be here. Thank you, Elad, Greg, and the team. I'm Idan, co-founder and CEO at Bluebricks. In my background, I started as we can say DevOps or sysadmin back in the days, 15 years ago. And since then, with the journey of building companies and software, Bluebricks is my third company. Previous one was Zest, and back in 2021 was acquired by WalkMe and turned to be the WalkMe workstation product today. So you can go to WalkMe website, which is, by the way, absolutely beautiful and great product. And search for WalkMe workstation. Today we tackle, and we started Bluebricks with two other co-founders, brilliant people. Pini Vaknin previously was the head of DevOps and cloud infrastructure at Transfit Security, and Nitzan Gindi, who's a product leader and a go-to-market brilliant guy, who's leading today the product at Bluebricks. What we do with Bluebricks is infrastructure orchestration. The approach we have to cloud infrastructure is a bit different. We believe that today we need to adopt new approaches, specifically if we want to integrate AI in this party. And I believe we'll talk about it today. And I'm here for any question, debate, and I'm not sure to defend AI, but let's get party.
Cool. So thanks, Idan. This was really like a great setup, and I'm sure we'll hear more about how that plays out in practice during the demo later on. But first, let's zoom in the problem that's driving all this innovation in the first place. Greg, over to you to walk us through why DevOps self-service so often breaks down in the real-world environment.
Thank you. So the problem itself isn't new, and we are been here for quite a while already. The main bottleneck of the, let's say, advancement of the infrastructure provisioning is a human. And I don't believe that it's very bad, and we will talk about my position about it. The current state of things is that bigger companies can afford themselves to build, let's say, IDPs, like internal developer platforms, where you can, with the help of it, build the infrastructure for your needs with the already pre-baked modules, pre-baked recipes. So let's see, if we're talking about Terraform, it will be modules, and you will have some guardrails there with the tests and other stuff, which will be making sure that the things you are building are compliant with the requirements and the policies. At some point, when you will try to provision that infrastructure, you might need the human supervision to do that, like another, let's say, infrastructure engineer to look into what you are going to create actually. And all of that is synchronous communication. So you need to, let's say, create a pull request from pre-baked modules, or you're using IDP and you're provisioning it with that, but still you have to have the manual approval. Usually it depends on the company policies. How do you put the guardrails, like, I don't know, budget limitations or scope limitations? But in the end, there's somewhere a human looking into it, because let's say, if we're talking about the companies which are ISO, PCI DSS compliant, they have a requirement to have a human supervising something, like a change management requirement. And what we were trying to do to solve it, like building IDPs, building self-service, and all of that still requires a human there. So developers either wait or like just YOLO and run, if they have ability, run the code by themselves without an expertise in the infrastructure provisioning, because software developer might not be aware of the specifics of the things they are making, how actually they should be configuring it, because it's out of their, let's say, scope of responsibility and scope of their knowledge, which is totally fine. And one of the solutions, potential solutions to solve that, is to use whatever we're calling AI right now, large language models. Doesn't really matter which one. All of them are trained on the corpus of texts of the infrastructure as code. Like, doesn't really matter. Pulumi, Terraform, CDK. They've seen a lot of open source repositories on which they've trained on, but they have their flaws. One of the ways of explaining how it works is that the LLM can produce the code which it have seen before. It cannot introduce, like, invent the new infrastructure code. It can assemble from the parts it have seen before. So we can write very good infrastructure code if it was on open source before, and we are mimicking whatever was open sourced. But with introduction of MCPs and RAGs, we can extend the thing. But I am not going to tell you how to do that. I assume that Idan will tell you how to do that, because he is on the position of telling that it's going to work. And while Idan will be telling you how is it going to work, I will try to find the holes in his armor and highlight the things which I believe are actually a problem. So let's move to from having an understanding of the problem. We have a human as a quality gate, human as a provisioner of modules, human as something which is synchronously working on provisioning the infrastructure. We want to move from that problem to something which will be giving us ability to unblock the developer without, like, waiting for a platform engineer, infrastructure engineer, DevOps engineer, whatever you call it, to provision the infrastructure. And let's hear what Idan can say us about what exactly we can do right now, like with MCPs, RAGs, and all other great acronyms.
Thanks, Greg. So let me start with what you said about humans. We are humans. We are creatures that are non-deterministic creatures, right? We have a mindset. We feedback based on what we see, what we observe, and this is how we react and behave. So the thing is with robotics and automation is that you are always seeking to deterministic approach. You want to have a consistent infrastructure, and specifically when it comes to cloud infrastructure or infrastructure in general. So unlike SDLCs and software development code bases, where there you can actually create one line, you are outcome driven. So you follow you have different paths to get this outcome that you're looking for. Imagine if you want to create a function that calculate numbers, you can do that in many ways. But when it comes to cloud infrastructure, it's different game and different play. So this is why I think that moving toward AI with deterministic approach and help the AI to be deterministic, this is the way to do that. Right now, with AI and agents, they are designed to be non-deterministic like humans. So they can actually see your feedback and get your input and then provide you with the feedback. And then once you actually respond, they respond to you. So when this is a session, and when you start a new session, then it starts maybe with the context and with the history that you have. But again, they are responsive to the input they receive. And the play here is how you actually narrow down the possibilities and choices they can choose from and how they can react. So I believe that today, as long as you are trying to work with MCPs, and for those who don't know what MCP is, it's a model context protocols. Like this is what Anthropic came and brought us, an easy way to connect between LLM and APIs. This is actually unlock the LLM world where you can integrate with anything almost. And the idea in here is that if you translate and you take the previous paradigm of having code and using LLM to generate the code to generate the outcome that you're looking after, let's say a new VM, a new database, a new VPC that is connected to a different one, a new YAML, whatever you want, a new Lambda function. And if you ask the LLM to generate the code, then you will end up with different permutation of the Lambda, different permutation of the VMs, and it doesn't really matter if you have a human in the loop or not, because the LLM will generate code. And then the process of pull requests and code review will actually be longer. But the different approach that we have in mind is that you need to tell the AI to choose from an inventory of building blocks. That way, the LLM makes the decision based on your needs, because you're actually saying, I need those needs, I need those capabilities. And the LLM actually behave as a sort of a DevOps, as a virtual DevOps that can actually pull those modules, connect them, and then provision them for you. So this is how today we think about agentic automation and MCPs in the cloud infrastructure and DevOps today. And if I'm taking you to practical examples, right? If you want to create, let's say, today, a pipeline, a CI/CD pipeline that take you from the moment that you want a Lambda function to the moment that you actually have it, then you probably need to add or to modify some infrastructure as code on configuration or any JSON or YAML file, whatever. Then you create a pull request. Then this pull request probably initiate something that will test the code or whatever. Someone else will review it and make sure that this is appropriate to this specific environment and click merge, approve, whatever. This will actually trigger either a plan, either an apply, but this is the process that will happen today. That way you actually add more and more code, and you are using humans to help you with that. So you can integrate with AI here to code review for you. But if you want to but the bottom line is that you as an engineer, you need to know what you need to write on this specific manifest file, Terraform code, etc. And it's easy when you see it as just Terraform file or just one coding language like Terraform, Pulumi, whatever. It's getting complicated when you have the real life, the complexity of different layers, right? When you have Terraform for the infrastructure, Helm charts for the clusters, when you have scripts that create keys or whatever that is supporting your application, then it's not necessarily just Terraform. So you need to do a few things in different places. And this is where agent can help you again. But if you expect the agents to actually create those code in different repositories, then it will be a nightmare for you. And this is at least my thesis, that if you want to move toward AI in this space, it's not like Cursor or Windsurf. You need to change the paradigm in how you work today to enable the agents to operate in the cloud infrastructure. Now, if you can actually point out to the holes in my cheese.
Yeah, actually, I believe it's a Swiss cheese. So let me start with. The first thing that worries me is that, let's say if we have a library of predefined building blocks, which we are using, let's say we're using MCP to retrieve those blocks, and we're building on top of it, we are reducing this problem to the problem I already highlighted, the problem of creating the building blocks. So now you are either writing them by yourself or you are vibe coding them without understanding what you are doing. So then, like, that's one of the topics. Another problem I see is that if we are talking about building something which is slightly more complex than just creating one VPC, and we have interconnection of a plenty of different aspects. Let's say we are provisioning a Kubernetes cluster into which we are installing software, to which software we are providing IAM permissions. We are creating a database and like end-to-end solution. We have to keep in mind that the modern LLMs have a limited amount of context they can keep. And there are cases where the models which have stated big context window are actually keeping in mind only beginning and the end of the context, and middle is gone. So we will have to apply techniques which will make sure that we are breaking down the problem into smaller chunks, which have the graph of connection. So let's say RDS is connected to EKS because we have to create security groups and maybe we need IAM authentication. So we will have to pass the context of this task to the LLM very carefully, like granularly providing it. And yet again, it's more amount of work. You need to understand, you need to build the graph of connections and to understand which context is connected to which. So all of that requires an automation. A product can do that. But let's say I will not be able to implement that in a very short period of time. That's a serious problem to solve.
Let's take it maybe before we
you want to take it one by one.
Yeah, and I think what you said, it's not like I'm thinking the opposite, but I just want to point out that when you want to automate things, you need to have the separation of concern in place. You need to have the modules, what you said. This is actually the description of your infrastructure and what is the business logic. And then the values. Like when you have charts, right? You have the values file and actually the chart. This is the same separation of concern that if you apply to all of your infrastructure, then it's getting easier to plug in different modules from the community, from the cloud vendors, from whoever you want, because you have this templates and then you have the implementation of them. And when you look at it as an ecosystem, then you have one place to maybe integrate agents, let's say create those modules. There you can use Windsurf. There you can use any code generation you want, or just pull them from Anton Babenko inventory. So you can create this template. And then the other side is the implementation, which is very specific, because I believe that most of the people that are attending this session have probably a Kubernetes cluster or a database somewhere, or something that is quite generic, but what makes it different is the values that they provide this template with. So you have this separation of concern, and then what you say, I agree. In between, you have the relationship between them. So if you look at it, all right, I have templates, I have values, and I have relationship. For each of them, I need to add the specific AI capabilities. By the end of this process, when you divide and conquer, you can actually have an ecosystem of agents that support you in the mission of creating and provisioning cloud infrastructure. I don't think that you have one AI agent that can do that all.
Okay, so let's make an assumption that we are creating like specialized chain of agents, which is writing the modules for us. The problem that I see is that we don't have a lot of training data for LLMs for test coverage of the infrastructure scope. Let's say if we will take the example of Anton Babenka modules. The modules are open source, but the tests for them are not public. So we need a corpus of texts which will contain the tests which will be validating the Terraform code, which is not really publicly available. Like you cannot find a lot of them on GitHub. So if LLM haven't seen before how to write proper tests for a module, it won't be able to reproduce that. So you will have to, yes, agentic mode will help with it, like through iterations and so on and so forth, but there is a place for a human because it's not that big amount of the tests. Another problem that I see is that compliance frameworks, which companies are applying today, their Terraform or whatever, like Chekhov, they are not public. They are like behind the as many closed doors as possible. So they have the repository internally, and the LLM haven't been trained on those tests too. So we have open source database of the Chekhov default tests, but their own internal policies are not publicly available. So we will have to use something like regs or MCPs to extend that knowledge of the agent. So all of that creates a layer on top of layer on top of layer of complexity of implementing that.
I agree.
That's not.
I agree, but I have an idea. I agree with you, and this is part of the changing the paradigm, because I think we are all engineers, right? We love to craft, we love to create, we love to write code. This is true, but when you think about the title and the job we have, we are in most cases DevOps. We are responsible for the operation of the development. And I think AI today is very powerful when you integrate it with the operation, because it's actually leverage. And think about it like in factories. What happened back in the days when you repeat the task and you repeat it faster instead of humans, machines, and then you can actually deliver much faster. And this increases the productivity. And I think this is the approach that we need to think about. If you are, and not mixing up, because when you look at it and you mix up the test writing task with the operation itself of pipelining, CI/CD, deployment, etc., then you won't be able to create an agent that does it all. It's impossible. But again, if you think about it, when we divide it and when we have this same concept of separation of concern, but this time for the different jobs and tasks that we need to do, then for the tests, I agree. If you didn't feature your LLM with the corpus and the data of writing tests, probably you will face some challenges and you might increase the productivity of yours, but it won't be 10x or 100. You still have to be in the loop until a certain point. But on the other end, if you actually leverage the AI to operate and help you with repetitive tasks and help you with small and making decision and be flexible enough to translate the needs of the engineers to the deployments that you need to do, think about it like the life cycle of creating a Jira ticket by the engineer, and then you read the ticket, and then, all right, I need to create a new VM. What would you do? And then this is actually this part of what you can delegate to the agent. But I will argue that to do that, you also need to leave the paradigm of writing everything in code and think like building blocks, kind of. Because when we take infrastructure and think about it again, this is like tables when you have one employee that's, I don't know, crafting and creating toys. When you have one table, then and you need to increase the capacity, probably you as the factory owner, you will add another table and another employee. And then at some point, another table and another employee. And it doesn't really matter what is the type of the table, the size of the table, the width of the table, whatever, the color of the table, it doesn't really matter because you have 3 tables. But if you have 1,000 tables, right? This is a table. This is a platform for me to work on. And I need 1,000 now. Now, the dimension, the size, the material, the cost, everything is super relevant for the table, because based on that, you can decide what factory do you want to rent, or all of the supportive features that you need to your factory if you want to be productive. And I think this is the same with cloud infrastructure. With cloud infrastructure, if you need a VM, if you have 2 VMs, it's easy. You don't need the consistency. But if you have 100 or 2,000 or 5,000, 10,000 VMs, you need to have an ability to create this consistency. And once you have it in place, and this is not involving code writing for each of them, but the separation of concerns as we discussed, then you can plug in AI agent quickly. And this is, I think, something that we need to sharpen when we think about our jobs as DevOps and leaders in the cloud space. What do you think, sir?
So I would agree with you. If we would be at the place where I can trust the LLM to do not hallucinate, or I would have such developed and advanced guardrails for it to protect me from the side effects of like taking a Jira task of creating a VM with a spec provided. By the way, we are talking about, if we're talking about separation of concerns, we will have to break all of that aspect into a smaller task to complete. First task is to make sure that the spec of the VM was provided correctly and validated. Again, we need someone to write the rules. Maybe it will be an agent, maybe not.
This is the humans. This is the humans, I think. The validation.
So the end form of a DevOps engineer in the future world is basically a nanny for the VMs, which is making sure that they are not crossing the lines. There are a lot of aspects.
Or defining
here,
what you want. Or defining what you want. You want an IO optimized DB or not?
Agree. There are a couple of more aspects of what, like, one of the things that worries me is that we are talking about the LLMs which are being run by the corporations like OpenAI, Anthropic, doesn't really matter, XAI. Not every company, I would say, like corporations which are working with healthcare, governments, and so on and so forth, will allow us to use tools like that. Something which is sending, I don't know, information about the resource arms outside of the protected perimeter. So we are moving into the place where you have to host your own LLMs. So it brings a lot of complexity there too. So you basically have to build your own. We have Llama, we have other implementations, but all of that is not removing the bottleneck of a human as an engineer there. It introduces more places where the engineer will have to work on, because self-hosted LLMs someone have to maintain them. But all of that is
I think the job
not
and
saying.
the work is evolving, and I agree
Yeah,
with you that at some point we'll
changing.
need to, we as, again, cloud leaders, DevOps, platform engineers, will have to adopt to the new reality. I agree with that. I think that specifically because what you said, when we see customers and companies today with their AI strategy and how do they look at it, I agree with you. Many companies today are not ready to consume AI. They know that they want it, but they are not ready, and they don't have a strategy in place of how to do that. And this is actually puts you in a position where you say, all right, I want AI, I'm not sure how. And then you start to think, oh, maybe this is not ready. Maybe this is not ready. But I will take this question that we have here, and I will argue that even with self-hosted LLMs, and even with the limitation of the LLM, how brilliant the LLM is, as long as we feed the LLM with the accurate data that we want, and then I think the decisions they will make, even if this is a poor LLM and not the latest module, right? They will be good enough for the operation aspect of it. I agree with you about the writing code because it's more complicated. But when you want to say, and when you want, bottom line, to provide your engineers with the capability to say, I want a new Python Lambda on EU, but like this task should be almost out of the box. And this is so complicated if you are sticking to the previous paradigm of having everything as code, like writing even this request as code. And I think this is the most important part when you start to think on AI in this ecosystem, how you change the paradigm, how you look at it from a different angle, and you think separation of concern. I think this is what we actually need to evolve to. This is the future. Otherwise, we'll stick to the previous decade, and we'll still think. And I agree with you. This is so complicated when you take Llama and you try to now, or Lovable, and you try now to create code that actually can provision whatever I want, which is a massive task.
So, Idan, Greg,
Yeah.
clearly we are not in a total agreement. But I think that's the point, right? Like these things are moving like quite fast. And with most of DevOps innovation, you know, this tension between speed and control, it's like a real thing, and we can see it now. So I think now it's time to take a look at how it works in practice. Idan, I think you've got a demo lined up. So we'll be happy if you show us this agent, like what they actually can do and how they work. What do you think?
Yeah, I'm fine with that. What I can pull out is a short video that we have. If you can let me share my screen.
Sure. And guys, meanwhile, please feel free, like if you have like questions, feel free to write like on the Q&A while the demo is being showed.
So what we have in here, the idea is, again, the separation of concerns. What we see is the VS Code of an engineer using Copilot and using an agent that, as you can see in here at the bottom right, is asking, hey, I am a new developer in the team and I need a new instance on AWS. That's it. Now, it was quite broad, right? With a requirement. This is a new developer that looking for a new instance. And this is actually where it gets interesting, because what we do at Bluebricks, we nurture the separation of concern concept. And what you can see is that the agent, we didn't train them. This is, if I'm not mistaken, this is Claude Sonnet 4. And this is actually listing the blueprint, or and then listing the environments, the available template and the available environments that you created earlier. as part of your job as the DevOps team. The idea is that when this is a new dev, you are delegating the decision to understand what is a dev environment to the LLM, because probably if you followed your naming convention, then probably the LLM can understand that. And this is what exactly happening in here. The LLM found the AWS EC2. And again, when you say instance, I can say VM, but the LLM is actually making the decision of translating this word to something that is related to the AWS. So it's AWS EC2. From your perspective, you can say, all right, I have a module that I want to set up. This is my AWS EC2 from my perspective as a center of excellence, as the DevOps, and I'll push it. And then the AI make those decisions. And see how simple is that? Like, we didn't train the LLM. This is generic Cloud Sonnet, but the concept of liberating AI and letting them to do that, this is what make it very magical. And we can see in here that this is actually saying that we have an environment, and those are the AWS environments, because maybe you are actually supporting more than AWS. So based on the prompt, the LLM make those decisions and say, listen, if you want to deploy it on AWS environment, those are the options. Choose one. And another thing, I need the properties. I need the name and I need the subnet ID. And then let's say that you don't know it because you are a new developer. So this is look what the developer actually saying. Deploy it to staging, and your suggestion sounds good because I'm a newbie. So let's go with you. Let's use the default based on the other question, the number 3 question, and like asking another thing with free language. What is the instance, for example, that suits the staging environment? Those are the things that we as humans will say, and will actually, when we think about the developer, they have no idea if this is a T3 small enough for the staging. So once we actually make the values and if we talk about the separation of concern, the values available for the LLM can make those decisions. So they are going to use the staging environment. They will name it according to the naming convention. They will use the default settings, and they will pick the T3 small. We didn't train Cloud Sonnet to do that, because he already assuming that if we are part of the AWS, plus you are asking for EC2, plus you are saying that I need something small or something that suits my staging needs, then based on the previous corps and data they have, they can come up with T3 small. If we were playing in the GCP or Azure, that would be the same, because the LLM holds the data. And bottom line, what you can see is actually the installation, because when I approve it, or before, you will see that I'm not approving it yet. Now it's running the installation. It takes a few seconds, and then you can see that it actually generates the outputs. And this is the beautiful part where you can keep the human in the loop, because you can instruct at Bluebricks that you want everyone to approve it or not. So actually, automatically, based on the output that you get from the system, the LLM can provide you a deployment summary and saying, you're about to create this, this, and that. This is the configuration. This is the cost impact. This is the security features. Those are the risks. And all of it is based on the LLM. We are actually leveraging the LLM to provide us with this information, that if we think about it, if you want to build it, how many open source tools would you need to connect together? From Atlantis to Argo to also LLM at some point to generate this output. So many tools. And this is when you adopt the separation of concern, you get it like this. So this is what you can see here. Then they approve it, and oh, voila. You have, as a new developer, it took them, like, the demo is 4 minutes. It took 4 minutes to actually get an instance that is compatible to your security restrictions, compliance, etc., on an environment with the audit, without even letting you or shoulder tapping you. It's audited, logged somewhere in the Bluebricks system in this case, and that's it. And this is already exists. So this is why I'm saying when you change the paradigm of separation of concern, then definitely you can have AI agent operating already. Yeah. Cheers for AI.
Amen.
Any
So I
questions,
have a
friends?
question for you then.
Yes,
Is
sir.
it fully deterministic? Like, is the module, let's say, we are freezing the temperature to be 0, we are configuring top K, top P, we like making sure that it will be outputting the same thing all the time, or if you will have the same prompt, you will have the divergence left and right in the output.
So the
How do you
idea is
control?
that if you have, again, it all comes to the separation of concerns. If you have this pool and pod of configurations, modules, etc., where you giving a name to them. Okay, this is my template to AWS EC2, right? When you have it right here, and then you have the other side as the values, then the agent can pull the data based on that. And everything that in between, this is based on the agent decision to make. But the output of the task is the same. You are using the same configuration, and then you fill it in with values. You can think about what you want to expose and what not, right? You can say, I want to expose the ability to make it a public bucket. Yes, no. This is you can control it if you have these two modules.
So if you have this type of, let's say, the combination of pre-existing rules and the inputs, it means that essentially the rule writing is now basically writing of the modules, which was like a bottleneck before. Because now your rule sets have to support whatever you want to do. If they are not supporting it, let's say our rule set as a company prohibits creation of a public bucket. And now you want to create a public bucket for a reason, but you can't. So how do we modify those rules now?
I would say that you're already doing it because you are creating the Terraform modules probably. You are creating the Pulumi code already. So probably the job and the task that you will need to focus on is to maybe create them much more according to your rule set. And all right, so this will be maybe shifting your focus too, because you will create this buckets as, all right, this is the structure of the bucket, but I want to enable two kind of buckets, public and private. And this is actually the work, and it's much more complicated work, and it's more related to your business. And this is actually making the DevOps job and role as more relevant for the business than it was before, because now you need to translate the business need, the security needs, everything related to that, to the modules that you create, and not being repetitive in the factory floor, as unfortunately sometimes you do it today.
Makes sense. And the only argument I have against it is that, but it's not fully formed with me yet, so it might be not that accurate, is that by creating that enablement of provisioning infrastructure with chatting with an LLM, which is using specific guardrails, specific modules, tests, and so on and so forth, we would be creating a sense of competence in the things which people are incompetent with. So like, imagine you are a developer who can provision a fully working Kubernetes cluster. It is good because I have no idea how my iPhone works. Like, no idea. Like, superconductors are above me. but I can use it. So we are creating such a layer of abstraction which removes the understanding of complexity of it. So there might be something we are missing, but maybe not. It's just a more a philosophical question than like a real practical one.
I love it that you're saying it, because when we started the company, so we thought, all right, we want to make infrastructure unseen, because we truly believe that today, if you need shoes, right, you go and buy shoes. And I think that cloud resources will be at this commodity level as shoes. Because now when you need electricity, you go to the wall and plug your iPhone. This is commodity. And I think that infrastructure should be free to everyone, to any developer. So if I want to enjoy Kubernetes clusters, I don't necessarily need to know how to configure it, right? And it's cool. Today you can consume it, but it's getting complicated when you have compliance, security, the enterprise aspect and the enterprise point of view. And this is what we wanted to do, and we are doing today, is by making the infrastructure unseen for the enterprises. Because I truly believe what you said. I need a Kubernetes cluster. I'm part of this organization. Just give it to me. I don't need to wait. I don't want to wait. Don't hold my horses, because I'm developing the business. I'm creating new code, new features, new capabilities. I'm fixing bugs. I'm making customers satisfied. Don't make the operation as hard as it is, like the Iron Ball. And especially when you have AI, where developers are becoming 10x more faster. You don't want to be this function that holds everyone back, because if the infrastructure will gone bad, someone will call you on Friday night or Saturday night and will say, listen, Kubernetes, the database max connection is reached. We need to fix it right now. So you don't want it. And this is why you need to change the paradigm to face the future. This is my belief.
Sounds too good to be true. Let's see. I want to live in that future without waking up on Saturdays on the call, but let's see. Hopefully, LLM will be waking up instead of me.
So, guys, I'm sorry to stop you. We have some questions from the audience. Let's start with the first one. So, isn't it better to ask agent to create you an infrastructure code for your requirements, so you will have a better visibility of what resources is he creating? Also, it will be much safer when you decide to destroy it. I'm asking because most of the companies are working with infra as a code in microservices. Ouch. Greg, Idan, who wants to answer? Or two answers, maybe.
Okay, I will give a quick answer. The whole point of using LLM in the topic of the conversation we have right now is to enable people who do not have specific skills. For me, totally makes sense to provision, like to generate the code for the infrastructure with LLM, read through it, fix it, iterate over it, make it good, commit it, apply it, here we are. But as well as software development, as well as any other activity, LLM is something which will work perfectly without guardrails, supervision, controls, whatever policies, if you understand what you are doing. So
Exactly.
for me, that will work for sure, no issues. But for a person who doesn't have the knowledge, context, and everything that is needed to produce the result, it will not work.
I totally agree with God.
Cool. Another question. I get it that it will be great for POC, but can't see a value for code delivery as part of CI/CD. Idan, I think it's for you. Yeah.
I'm not sure that I understand the
I'm
question.
struggling.
I think the question is it's
This
good
is
for
a
like
question or a statement?
Yeah, exactly. I think what he's asking is if it will be like good for POC and not for production, probably.
I would say this is like a
Yeah.
stellar opportunity for me. I would say let's do it. Let's face it and let's see. If you think it's not good enough, let's prove it. Because what we see today is that for POC, you don't see the value because it's not just a cool thing. Like it's fun, but the value, the massive impact is when you have complicated environment and when you have many consumers to cloud. They can be DevOps, they can be requests. The consumer don't necessarily to be an engineer or a human. It can be an API. We do see that in some of our companies that we are working with, we definitely see APIs that triggers provisioning to support some of their services. So they used to have it like a Slack channel request or a CI/CD pipeline that add another like a block of code within the Terraform and then reapply it and over time create massive blast radius. So such things we can actually, when you have it, this separation of concern in place, then you can actually skip it. And when you add AI to it, then you don't have to be explicit. And this is the cool magic here, because the API can say, I need a new database in Europe, instead of the API to be known what is the Europe slug name environment, or what is the actual module that I need. So you can just say, if my service now needs additional support in Europe, in Western Europe, then this is what they can say, and automatically we get it. And this is real scenarios that we are facing and working with today. It's changing the world and how fast you can actually hit the market.
Greg, agreed?
I didn't understand the question, so I will agree with it.
Okay, I think last question. This is also like a long one. Looking at the demo, it's clear that prompt chain operations through tools, in this case MCP servers, in this scenario, the MCP metadata must be populated with relevant context. However, the interaction graph is not shown. How can we influence the behavior by rewriting or reconfiguring the MCP? Does the decision-making rely on the metadata of the MCP tool? And is the graph constructed directly by the model within the single session? Is this referring to an understanding of the actual structure, or is the MCP working under the hood for RAG with indexed data about the current project, possibility involving some kind of simple graph? Idan, I think it's for you.
Definitely, but yeah, it was a long one. What I can say is that you can definitely, so the way you manage, first you can choose based on your organization and what you want to enable. You can choose what servers for the MCPs you enable as a DevOps. So you can say, I would like to enable listing values, listing environments, etc. And based on the permission for the consumer, they can get the relevant results. In addition to that, if you install the MCP, you can provide a baseline instruction for the MCP. So you can say, be very specific or elaborate or graph the output in that way, or do not ask, or you can add more baseline instruction for the MCP so you can control the behavior of your team. And this is also, you can manage it based on different teams. For, let's say, for front-end teams, you can do that. And for back-end teams, you can do this. And lastly, I didn't really understand the second part, but it sounded very interesting, actually. And I'd like to deep dive if possible. I'm not sure who's the
Yeah,
who
it's an
asked it.
Someone anonymous asked it. So
Hmm.
if you want to write anonymous, like to clarify it, it would be great. And I think, okay, let's wait. But anyway, we have like another one. Probably it's like for both of you, so you can answer together. How far are we from being replaced by AI agent? Current limits are not accurate enough, and sometimes I end up with dead end when trying to solve a problem.
If you allow me, I will start. So
Sure.
not really close. The root of this is that the LLMs are non-deterministic until you make them deterministic. What I mean is that you can kind of make them deterministic by controlling the temperature, the top K, top P, whatever. But then you're losing half of the like beauty of it. But in order to replace a DevOps engineer or software developer or whatever, the tool should be first trained on the same or better corpus of the information that the engineer was trained on. Because let me give you a simple example. I usually use it when I talk with other people about LLMs. Ask DALL-E or any other model to draw a person writing with the left hand, or to draw the analog clock with the arrows pointing not like this. It won't be able to. And it's an illustration. It has nothing to do with the DevOps. It's just an illustration of those modules are capable of doing something which they saw before. And they are being trained on the publicly available information, maybe some not really publicly available information. But the real world doesn't consist of only that information. And the task of cleaning, gathering, and producing all of that information is very difficult. And by the way, ladies and gentlemen, when you are prompting your code to the LLM, keep in mind that potentially the companies you are using the LLM from are training their future models on the things you are sending to them. So the answer is not really soon. And there is no, if you haven't been following this debate, there is a lot of places where there is a need for a human, because LLM right now will not be able to write the guarding rails for itself. LLM will not be able to do this and that. So they are not replacing us right now anytime soon. What they are doing, they are empowering a lot of us to do things faster, better, so on and so forth. But it requires you to be like a specialist in something which you are doing if you want to achieve like really good results. Sorry for a long answer.
And I want to be the devil. And I think that if you want to evolve with the mindset and how you work, then AI will eventually replace you. Because I think that the way it works today and how fast it's evolving, we need to change the paradigm, and we need to change how we work and how we treat things. Otherwise, we'll be part of the previous decade or the previous era. And it happened with different technologies where people stick to the previous trends and do not learn and do not evolve and do not think differently of how to use and leverage the technologies, then definitely you will be replaced. So my advice is definitely to start think how you actually integrate the AI with your daily work, and not necessarily as an assistant, like a coding assistant. This is obvious, but think about it from the operational perspective of your job, the ops in the DevOps.
And
So
I will
great.
even agree with Idan. Like, if you will not be adapting, you not completely. If you will not be adapting, you will not continue this race. Like IT, as long as I am working in IT, is constantly evolving. If you are for, let's say, for the span of 5 years doing the same thing without learning the new skills, without improving, adapting, you're basically out of the race. You are not that competent, you are not that demanded on the market. So that's yet another like stage of it. It's not like a revolution. I don't believe that it's a revolution. And mostly I don't believe because I don't believe that it is artificial intelligence. It's a large language model producing tokens, output tokens based on the input tokens with some stochastic processes inside. It is not an intelligence, but it's a different, like a philosophical conversation. We don't have like generic intelligence right now. We have like text producing. Anyway.
So Greg, Idan, thank you for such an open and guarded conversation. Like everyone, thank you, like on behalf of Naviteq and Bluebricks, thank you for joining for this webinar. For those of you who missed it or would like to watch it again, we will share the recording in the next few days, like publicly. Thank you all for joining. Again, thank you, Idan and Greg, for this great debate. And see you, everyone, on our next webinar. Thank you.